In this lesson, you are watching the continuation of our geometry review from grade 7. This will cover reflections and translations regarding geometric shapes on a grid. So shapes on a grid. So first off, we need to go over, well, what is a grid, right? What are the parts of a grid? Well, here we have a picture of a grid. This part here is called quadrant 1. So there's 4 parts, so each part is called a quadrant. This is the first quadrant. This is the there we go. This is the second quadrant. This is the third quadrant, and this is the fourth quadrant, right? Knowing what quadrant you're working with is important because sometimes they'll ask you, a question will ask you, move this from quadrant 2 to 3. Well, if you don't know where quadrant 2 or 3 is, you won't know where to move it to or move it from. So knowing your quadrants is important. What's also important is knowing the origin. The origin is the 0, 0 point, the center of your grid. Many questions will ask you, rotate, reflect, move around or through the origin. And if you don't know what the origin is, you don't know where you're moving to. And these two are probably the most important parts. These parts are called the x-axis and your y-axis. Your x-axis is your line across the center horizontally, and your x-axis is your line across the top and bottom vertically, right? Many students make the mistake of confusing their x-axis and their y-axis, and this is what will cost them marks and grades from math from grade 8, 9, 10, 11, 12, because the grid shows up a lot and you'll use it more and more, and your x-axis and your y-axis are very important. So know what is your x-axis and what is your y-axis. So knowing the parts of a grid and knowing what axes we're using, we can find points on a grid. So here we have 1, 2, 3, 4 points, and we need to find where they fit on the grid. Here we have bracket 1, 3. This is the proper notation for writing points. If you don't put brackets in, sometimes you do lose marks. So you make sure you write this correctly, bracket 1, 3, bracket, and the 1 in this point refers to your x-axis. The 3 on this point refers to your y-axis, right? That's how you write a point on a grid, or represent a point on a grid, right? Many students mix it up. They go, oh, okay, I'm going to make this the y and the x. Don't do that, you will lose marks. And you will get confused when on a test or an assignment, they're giving you points to dot or grid. So, for example, a mistake a student would make is, oh, this is 1, 3. Well, then it's 1, 3, right? And that's wrong, right? Because this 3 refers to your y, which is up and down, and this 1 refers to your x, across. So instead, we look at this. Where's 1 on our x? So x, 1, and 3. Where's 3? There. So that's where the dot goes. -4, -3. Again, I look for the -4. Oh, way over there. So that's the -4 for our x. We don't leave the dot there because we're at -3, so we find -3, right? Here and here. That's where -4 and -3 meet. -3, 4. So we go 1, 2, 3, -3 here, and then we go up 4 right there. Take another point, 3 and 3, 3 and 3. There you go. That's it. That's how you plot points on a grid. And it's relatively easy as long as you know A, how to write your points, and B, know that it goes x, y. Your x point, then your y point. And know which axis is which. Because if you make that mistake, then you're going to end up with a weird shape or dot. So what are the points of the shape of this triangle? So we have this triangle, right? And I want to know what my points are. So we have this point on this triangle, we have this point on this triangle, and we have this point on this triangle. So what is this point? Well, I would write it as bracket, right? Where's my x? 2, because your x is always first. So 2, comma. Okay, what's my y? 2, perfect. So that's one you really couldn't mess up. Then you go to the next point. We'll use this one. So you go bracket 4, right? That's our x-axis number. 4. Oh, and we go up to 2. So 4, 2. And our third point. So it's at 3, right? So we go 3, comma, 4. And there you go. So now we have the 3 points that make our triangle. And questions on tests will say, oh, you have these 3 points. What does the shape mean? What shape do you have? So you will just have these 3 points sometimes, and they'll say, what's the shape? Or they'll give you the shape, and they'll say, what's the points? So knowing your x and y axis, knowing how to write your points, and knowing it goes x value, then y value, is important for a multitude of questions. So a translation is a type of movement for a shape. So when you're translating something in terms of a grid, you are moving a shape an amount of spaces. So in this question, I'm asking, translate this shape 3 spaces down. What are the new points? So this triangle is the same as this triangle, I just shrunk it a bit. It's the same grid, everything here. So we have 2 and 2, 4 and 2, and we have 3 and 4, just like before. Okay, so I want to move this triangle 3 spaces down. But normally, on a test or on a question, you can't just click and drag your triangle. You have to move it by hand. So first, what you want to do is find your 3 points. Now, we already did this before. We know these points to be 2 and 2, 4 and 2, and 3 and 4. So I want to move these spaces 3 spaces down. 3 spots, 3 spaces down. So I go 1, 2, 3. What's this new spot? We have -1 and 2. Oh, sorry, 2 and -1. See, I made that mistake. 2 and -1. So x value is 2 and y value is -1. And then you go here, 1, 2, 3. X value is 4, comma, -1. Right? And then we take this point and we go down 1, 2, 3, right? And we have the value 3, right? Because I'm moving it down. I'm not moving it across. So as you notice, our x values are staying the same because I'm moving 3 spaces down, not across. If I were to move 3 spaces across, our y values would stay the same and our x values would change. So 3 and 1. Right? And so this is our new triangle that has been translated from the original down. So if you don't know your points, if you don't know your spots, you can't translate a shape. Reflections, they're a little trickier. They're basically what you do when you copy a shape and move it across an axis. So if the shape is reflected across the x-axis, then the values switch signs. The y values switch signs. If you reflect on the y-axis, the x values change signs. So again, we have the same triangle here, right? And let's say I want to reflect this shape on this side. So I'm reflecting it over which axis? Which axis is this? Y, right? This is our y-axis, and this is our x-axis. So I'm going to reflect over the y-axis. So here it says, if the shape is reflected on the y-axis, the x values switch signs. So 2 becomes -2, but we stay here, right? Because the y values stay the same. Same as here. So you go -4 and 2, and we have the shape here. So this is the reflection, not perfect obviously because I can't draw perfectly, but this is the reflection of this triangle over the y-axis, right? And as you can see, This, from the y-axis, this triangle is 2 spaces away, and from this triangle, 2 spaces away. It's like looking into a mirror, right? The mirror line is our y-axis. So let's say I reflect over the x-axis. So I want to reflect over this way. Well then, our y values switch signs, not our x values. Our y values switch signs. So common mistake is that if you're reflecting over the y-axis, you will flip your y values, but then you've just reflected over your x-axis instead. So if you reflect over your y-axis, you're changing your x signs into their opposite. So if you have 2 as your x value here, and you reflect over the y-axis, it's -2. If you have the 4 over here, and you reflect over the y-axis, it's -4. So we're reflecting over the x-axis. Okay, so again, we have 2 and 2, so we flop our, our y value, and we flop the y value here, right? Again, 2, and this one flops to -4, and we have our reflection of our triangle over the x-axis. And again, 2 spaces from the mirror line, 2 spaces from the mirror line, they're the same, so it is a proper reflection. So here we have another one, reflect the shape over the x-axis. Well, step 1, what are our points? What are the original points for our shape? That's step number 1. Again, x value versus y value, right? So step 1, we'll just pick some points. Yeah, here we go. We have 2 and -1. So our point here would be 2 for our x value, because it's 2 here, and -1 here. So -1. And then we have here 4. So our value here is 4. And we have -1. Now you don't have to do the same points I did, like this one across from this one on the top. You could do the top first. It doesn't matter. I just like doing it that way. And here we have, now you can't see it because the triangle's in the way, but that's in between 2 and 4, so that's a 3, right? That's a 3, and this guy is a 1, right? So those are our 3 points. Now we want to flip over the y-axis. Now I need to find my y-axis, which is this guy right here, vertical, horizontal. So if I flip over the y values, or I made a mistake. Reflect over the x-axis. So you flip it over the x-axis, so you want to flip over your y values. So here we have 2 again. We end up with 1. We have 4, right? And we have 3. And we're flipping our y values to make this 1. And we're making this -1, right? So let's find our point. We have 2 and 1 here. Let's use a different color. Let's use black. 2 and 1. We have 4 and 1. And we have 3 and -1. 3 and -1. So our triangle is like that. And that's the reflection over our x-axis. I keep almost saying y-axis. Over our x-axis. So once again, if you reflect over your y-axis, you flip your x values. If you reflect over your x-axis, you change your y values. Like so. So this one you can do on your own. Again, you write down your points of your original. You look at what you are reflecting over. So here in this case, you're reflecting over your y-axis. And you want to just pop it over by flipping your x values. This YouTube video will quickly go over those points, and we'll continue on from there. So, rotations. A rotation is when you rotate around the origin or the middle, like so. You see this triangle? I've rotated it over. I've rotated it over. I've rotated it over. A trick you can do is just literally take your grid, your paper grid, and just rotate it. And you will get what the triangle will look like in its new form, its new position. And this video will go over that as well. So, rotate this shape over 90 degrees. So, what are the original points of this, right? And again, it's 2, 1, 4, 1, and 3, 3. right? So you'd write that down and then move each point equal to the angle, right? So you just rotate, right? Here we have the point. We'd rotate 90 degrees. We would rotate 90 degrees. And we would rotate 90 degrees. And then you'd end up with your points here and here, right? So you can see that there, 2, -1, right? That becomes our new point. Here we have 4, 2, 3. We have 4, 1, and then it turns to 2, -3. And then we have 3, 3, which turns into 4, -2. And you'd end up with your rotation of 90 degrees. So the cheat for this, and it's much easier than the other way, is just to rotate your paper, right? So you have 2, 1, 4, 1, 3, 1, and you rotated it this way. And I've just flipped the side. I've just taken the paper, I've taken this guy right here, and I've just spun it clockwise. So I've spun it clockwise, like so. Boop. Well, it doesn't come with it, but because they're not connected to the same thing. But if you rotate the whole shape, well, now you have 1, 2, 3, 4, right? 4 down 2, -2, right? So the numbers aren't matching because I've spun the paper around, but if you know what your grid is supposed to look like, then you know what the rotation is going to be. So a rotation is even easier. You don't have to do any real measurements. You just rotate the piece of paper equal to the angle of turning. So 90 degrees, 180 degrees, 360 degrees, and you will get your new grid and where the shape will be on that grid. And that's basically it. That covers translations and rotations. We will go over this much later, probably around March, May, around that time. But it's good to know this because it will come up again. All right, thank you for listening and see you next class.